All right, everybody, so today is October 28th. Go ahead and open up your notebooks. Today we are going to talk about scatterplots, okay? Go ahead, I want you to pause this video, and I want you to identify which of these graphs have no correlation, positive correlation, and negative correlation. All right, so the one that has a positive correlation is going to be the first one. The second graph, you should have picked negative. And then the last one has no correlation. All right, so update your table of contents. Again, today is the 28th, and we're talking scatterplots today. As a reminder, tomorrow you guys will have a notebook check. I would definitely make sure your table of contents is up to date along with your entire notebook. Okay, so we're working on learning about scatterplots. You want to go ahead and write down these two definitions. Number one, what is a scatterplot? It's a graph of plotted points from collected data. Now, what is correlation? It's the measure of the strength of that data, okay? So like we saw in the warm-up, we can have positive, we can have negative, we can have no correlation, and then we're going to use some other terms to describe correlation here shortly. All right. You probably want to go ahead and pause the video so you can copy all of this down because there is a lot to copy down here, okay? I'm just going to go ahead and start reading through it. But like I said, I suggest you pause it so that way you can get everything written down. When the data is neutral, that means there's no correlation. We're going to call that a correlation coefficient of 0, okay? Our second type of correlation is strong, okay? We can have points that are close to the trend line when we are strong. So for instance, on those two graphs that you see, there's a positive strong and a negative strong, where all the dots are all very close to that line. If I added more dots, I would see all of them are very close. None of them are way far out. My graph is increasing, and in this case, my correlation coefficient is going to be closer to 1. When I'm negative, though, that's when my line is decreasing. I still have strong because my dots are still close to the line. However, my correlation coefficient this time is closer to -1. Makes sense. Positive is closer to +1, negative is closer to -1. If on the other hand, we are weak, okay? Weak is where the dots are not close together. They are very spread apart, okay? They have correlation. They're all going in the same direction, but they're all very spread apart. If I'm positive, that means I'm increasing, but this time my correlation coefficient is closer to 0.5. On the negative end, though, if our graph is decreasing, our correlation coefficient is going to be close to -0.5. You do want to make sure that you know these numbers. So if I am weak, I'm closer to 0.5. If I'm strong, I'm closer to 1. If I am no correlation at all, I'm going to be more on the 0 end. All right, so now that we know this, let's go ahead and determine our correlation coefficient for the following. What you want to do first on these type of graphs is draw your line of best fit. Your line of best fit is that line that we saw previously in our graphs. This line right here that tells me kind of the direction that all my dots are going. But we have to draw that. So we want to draw a line that's going through kind of majority of the dots. So for us, I see it kind of going right about here. So here I see a lot of the dots are very close to my line. So that tells me that I am strong. From left to right, I see I'm going up, meaning I am positive. If we are strong positive, look back at your notes. What does it say for strong positive? Strong positive, we said, is closer to 1. So that means I'm going to be closer to 1. You can put 1, you can put about 0.9, anything like that. Anything that's closer to 1 would work here. All right, so on this next one, go ahead and see if you can figure out what you think the coefficient is going to be. All right, so on this one, let's go ahead and let's name this correlation coefficient. On this one, I'm going to draw my line of best fit, which is right about there. Things I notice is that I am weak in this case, and then I am negative. So weak says I have to be closer to 0.5. Negative says I need to have a negative sign. So what is weak and close? What do I think this is? And again, this is just kind of an estimate. We're just making an estimate of about what we think it is, okay? So if I put an estimate on this, I would say maybe about negative 0.3 is about what I'd say on this one. All right, let's go ahead. Let's try this next one. This next one, let's see. I'm not seeing us going up. I'm not seeing us going down. I'm kind of seeing it all over. Whenever all my dots are all over the place, that's where I had no correlation. So my correlation coefficient here would be 0. Okay, now the next one, again, draw a line that's going through a majority of the dots as best as possible. That's your line of best fit. Okay, if I'm looking at this, I am going in the positive direction. My dots are very close, so I am strong. So meaning I need to be closer to 1. I don't want to be close to 0.5. I want to be closer to 1. Now, some of the dots are kind of away from that line. So maybe I would say I'm in between 0.5 and 1. So maybe I'm about a 0.7. All right, here on this next one, it asks us to use the data to make a prediction of how much they weigh if they run 3.5 kilometers per week. In these cases, what you want to do is you want to go ahead and basically read the graph for what they're asking. Go at 3.5 kilometers. Okay, there's 3.5 kilometers. Well, you probably want to go ahead and draw yourself a line of best fit. When you draw your line of best fit, you can see where those two intersect. And we can guess about what we think this is going to be. This is going to be about, I didn't draw that line that very straight, but I'd say about 86.5 or 87, one of those two. Use the data to make a prediction of the speed of sound when the air temperature is 45 degrees Celsius. Go ahead and pause the video and see if you can make this prediction. All right, if I draw my line of best fit, there it is. Go to 45. Let's go take a look and see what we got. So I'd say about 357 miles per second. All right, last thing that we want to talk about is this cause and effect relationship. okay? This is honestly just as easy as you guys might think it is. For each of these, you want to determine whether the following statements represent a causation. So basically, you want to decide if this statement, the cause, would represent this effect. So the more people who smoke, the number of people who have lung cancer increases. Basically, this is true or false. It's true or false. Well, the more people who smoke, lung cancer increases. I'd say that's true. The more students in KEISD, the fewer teachers the district needs. That's going to be false. The more you exercise, the healthier you will be. Is true. The larger the project, the fewer people you will work with. That is going to be false. And that's it for today, guys. That's all your notes. Go check your module, see if there's anything else that you need to complete for today.